In Chapter R, we took a look at how to evaluate exponents. But now, in order to really deal with exponents and use exponents in radical expressions and to convert radical expressions to numbers with rational exponents and be able to manipulate them, we want to make sure we have a solid understanding of properties of exponents. And if you're watching this video in terms of looking at Chapter R.7, don't worry about rational exponents just yet. Those will be coming. But first, let's just take a look at the properties of exponents. Let's say that let's define what we're going to call the product rule. That's going to be called the product rule. So let's say that I have a number to the fourth power, and I'm going to multiply that by a number to the third power. Well, if we were to expand this out, if you watched the earlier video, you would understand that a to the fourth power is a times a times a times a. That's a to the fourth power. And if I want to take a also, if I want to multiply that by a to the third power, then that would be times a. So a to the fourth is here, a to the third is here. And if I multiply those together, I will realize that I have a to the 1, 2, 3, 4, 5, 6, 7th power. So a to the fourth times a to the third is a to the 7th power. Well, if I take a look at my exponents up here, I notice that 4 plus 3 is 7th power. That's how I get that 7. So the product rule states that whenever I am multiplying the same base, whatever the exponents are, all I really need to do is add the exponents. Let me clear this for a second and we'll take a look at the next rule, which is called the quotient rule. So according to the quotient rule, if I if I have a number a, and let's say I'm raising that to the fifth power, and I want to divide that by the same number a, and this time I want to raise it to the third power, well, that would be the same thing as saying a, so making a copy of a 5 times, right? A times a times a times a times a, that's 5 of them. And I want to do it again, I want to divide that by a to the third power, which is a times a times a. Well, notice that I have several ones here. I have a 1 here, and I have a 1 here, and I have a 1 here, and that leaves me with only the 2 a's up top here. So that would be the same thing as saying a squared. And notice that if I just took a to the 5 over 3 and I rewrote it as a to the 5 minus 3, then that would be a to the second power. So the quotient rule says if I am, and I know I'm going really fast, if I take a to the m power and I divide it by a to the n power, some arbitrary powers, they could be the same. Let's take a look at that in a second. But that is equivalent to a to the m minus n. And that makes a couple of very interesting situations for us. The first interesting situation happens when I have a, say, to the third power over a to the third power. We know that this is a number over itself, and that any time we have a number over itself, we have the quantity of 1. But how that conforms with our quotient rule is that I basically here have a to the third divided by, well, a to the third divided, I've got that written there, that's a to the 3 minus 3. And of course 3 minus 3 is 0. So a to the 0 power is 1. And that gives us our 0 exponent rule. Our 0 exponent rule, which is that any number to the 0 power is 1, is the identity 1. The second interesting situation happens when I have a bigger number in the as an exponent for the denominator versus the exponent in the numerator. Notice here that I have a to the 3 over a to the 7, which is a to the 3 minus 7. And that's equivalent to a to the 3 minus 7 is a negative 4. Well, what happens when I have a negative exponent? Let's take a look at that expanded right here. When I have a negative exponent here, I have a 1 there, and a 1 there, and a 1 there, and I have 4 a's, but they are now in the denominator. I'm multiplying a by itself 4 times, but they are now in the denominator. So what this means, this is equivalent to saying 1 over a to the 4th. Whenever you have a negative exponent, then you take the reciprocal of it, and then you make the exponent positive. That would be the same thing as if I had, that rule still applies if I have a negative exponent in the denominator. Let's say I had 1 over x to the negative 6th power. Well, to rewrite that with a positive exponent, I would reciprocate it. I would take x, or x over 1, to the positive 6th power. And so what this is called is our negative exponent rule, or I like to call it the inverse rule of exponents. And how that goes is whenever I have a negative exponent, then I take the reciprocal of it, and make the exponent positive. And so the last rule we want to discuss is called the power rule. And the power rule simply states that if I have a number raised to a power, I want to raise that to a different power, let's say the 3rd again. Well, what I've got there is a times a times a 3 times, right? A times a times a times a times a. Or basically I have a times itself 9 times. So what I have is a to the 9th power. Or basically what I can do is take my exponents when I have an exponent inside parentheses and I raise it to an exponent, then I will simply multiply my exponent. So the power rule goes a raised to the m power, raise that to the nth power, that's equal to a to the m times n. Very much a simplified set of rules. We will go over them in much more detail in future videos.